Hello everyone. In this video, we will focus on this problem. We are asked to find the standard equation of the ellipse given point P at 6, 0, vertex at 0, -8, and the second vertex at 0, 8. These are the three given information that we have. Okay, let's start. First, let's write down the standard equations of an ellipse. We have two standard equations. The first one is x minus h squared over a squared plus y minus k squared over b squared equal to 1. The other equation is x minus h squared over b squared plus y minus k squared over a squared equal to 1. Notice that the denominators are switched. Some students are confused with which of the two equations to use. So that's your first challenge. Figure out which equation to use for this problem. Remember this. A is always associated with the major axis. Why? Major axis is the largest diameter of an ellipse. And A is actually the largest radius of an ellipse. It's 1/2 of the largest diameter, or 1/2 of the length of the major axis. If your major axis is vertical and vertical is associated with y, look at your xy plane. The vertical axis is y, the horizontal axis is x. That's why vertical is associated with y. Likewise, horizontal is associated with x. So if A is always associated with the major axis, and if your major axis is vertical, and vertical is associated with y, then A should be placed under y. Look at the second equation. A is under y. Therefore, use the second equation when the major axis of your problem is vertical. If your major axis is horizontal, and horizontal is associated with x, then A should be placed under x. Look at the first equation. A is under x. That means you will use this equation when the major axis of the given problem is horizontal. Okay? The first step is to figure out which of the two standard equations we are going to use for our problem. Let's plot the vertices. We have the first vertex at 0, -8. The second vertex is at 0, 8. vertices are the endpoints of the major axis. So if we connect the two endpoints of the major axis, we form a vertical line segment. Therefore, the major axis of this problem is vertical. So if our major axis is vertical, then we choose the second standard equation. And we will discard the first standard equation. This will be our focus. Next, we need to know the center of the ellipse. The center of an ellipse is represented by HK. H is the x-coordinate of the center. K is the y-coordinate of the center. The center of an ellipse is the midpoint of the major axis. This is our major axis. Obviously, the midpoint of this line segment is at the origin, at 0, 0. If you want to validate the center using the midpoint formula, you take the average of the x values, 0 plus 0 equals 0, divided by 2, 0. Take the average of the y values, 8 plus negative 8, 0, divided by 2, it's 0. Okay, so you can figure out the center by inspection or by using the midpoint formula. The same center at 0, 0 will be the result. Okay, so we know that H is 0, K is 0. You plug H0 and K0 into this equation. This will be simplified into x squared over b squared plus y squared over a squared equals 1. X minus 0 is still 0. X minus 0 is still x, and x squared is x squared. Y minus 0 is y, then squared, it's y squared. Next, we need to know the value of A and the value of B. Remember that A is associated with the major axis. A is the distance between the center of the ellipse and vertex of the major axis. So from this point, the origin up to this point, it's A, and A is 8 units from the center of the ellipse. The denominator becomes y squared over 8 squared. Next, we need to find out B. Let's use point P at 6, 0. So it's on the ellipse. Let's plot 6, 0. Therefore, the ellipse looks like this. half of the ellipse. Notice your point P at 6, 0. It's collinear with the center. That means this point P at 6, 0 is actually the co-vertex of the minor axis. Minor axis, just like the major axis, passes through the center of the ellipse, and it's perpendicular to the major axis. This is actually half of the minor axis. We can guess the other co-vertex of the ellipse is at 6, 0. So this line segment is the minor axis of the ellipse. Our ellipse looks like this. Okay? B is the distance between the center of the ellipse and the co-vertex. From this point up to this point is B. And B is equal to 6 units. Therefore, we can now replace the denominator by 36. B squared is equal to 6 squared equal to 36. So the standard equation of an ellipse with point at 6, 0 and vertices at 0, -8 and 0, 8 is x squared over 36 plus y squared over 64 is equal to 1. Another way of finding out b squared is by substituting x equals 6 and y equals 0 into this equation. If x is 6 squared over b squared plus if y is 0 squared over 8 squared equals 1. B becomes solvable. 0 squared is 0. 0 divided by 64 is 0. 6 squared over b squared equals 1. Let's write the invisible denominator 1 on the right. Cross multiply. 1 times 6 squared is 36. B squared times 1 is b squared. Then you plug b squared equals 36 into this equation. Simplify 8 squared, it becomes 64. The equation is still x squared over 36 plus y squared over 64 equals 1. Okay, so this is the standard equation for our problem. If you have questions or clarification, please leave a comment. Don't forget to subscribe to my YouTube channel. I am Tutor Marife MCP. Thank you for watching.